Now we go to the next theorem, that is perpendicular from the center bisects the chord. So if this is a chord and if I draw a perpendicular, then the theorem says the perpendicular bisects the chord. So what we need to do is just join OA and OB and prove these two triangles congruent. So this is perpendicular, so I can say that angle 1 and 2 are 90. Angle OMA and OMB are 90. OM is OM common, right? And OA and OB are equal because they are radius. So we have three conditions: OA equal to OB because they are radius, OM equal to OM common, and angle 1 equal to 290 because this is a perpendicular. So triangles are congruent by RHS. And if the triangles are congruent, then I can say AM equal to MB. So perpendicular always bisects the chord. Perpendicular from the center bisects the chord. Just remember this because this will be used in the questions. So this is the second theorem. Perpendicular from the center bisects the chord. And the converse of this, the line drawn from the center, bisecting a chord is perpendicular. Or if I draw a line from the center to the midpoint of the chord, then we have to prove that this is 90. Okay, it's the converse of the theorem that we discussed just now. The line drawn from the center to the midpoint of a chord is a perpendicular. Now I have to prove that these two are 90. So OA and OB are equal because they are radii of the same circle, radius OA and OB. AM equal to BM. Why AM equal to BM? Because it is given that this is the midpoint, because this line is bisecting the chord. Bisection means division into two equal parts. So AM equal to MB is given to us. They have written Y, so we have to write here given. OA equal to OB, radius. OM equal to OM common. So we have three conditions with us, and now we can say triangles are congruent by SSS because all three sides are equal. And if the triangles are congruent, then angle OMA equal to angle OMB, CPCT. OMA equal to OMB, CPCT. And we know that angle OMA plus angle OMB will be 180, linear pair. By linear pair, this total is 180 and they are equal, therefore they have to be 90 each. So OMA equal to OMB 90. And if they are 90, we can say that this line is a perpendicular. So line drawn from the center of the circle bisecting a chord or midpoint of a chord is a perpendicular, or this line will be perpendicular to the chord. This is our theorem number 9.4. Next theorem, equal chords are equidistant from the center. Equal chords are equidistant from the center. If we have two chords which are equal, then as per the theorem, their lengths will be equal. So here we have equal chords. Let's say we have AB and CD, equal chords, and we have to prove that the distance from the centers are equal. So I have to prove that OM equal to ON. Equal chords are equidistant. So OM equal to ON, I have to prove. So construction, I am going to join OA and OC. I'm going to get two triangles and I have to prove OM equal to ON. And what is given to me is that the chords are equal, AB equal to CD. So equal chords are equidistant from the center. This has to be proved. So here, what I need to prove is OM equal to ON. So I'm going to take the triangle OMA and ONC and prove them congruent. So this is the distance. Distance is always the shortest distance. When I say distance, it is not like that. The shortest distance is always a perpendicular. That's why I made this 90. So when I say the distance of AB from the center, that is a perpendicular line. Distance of CD from O, this is ON, that is a perpendicular line. So first condition, we can say that angle M and N are 90. Second condition, OA and OC are equal, radius. OA is radius, OC is radius. Both of them are equal to each other. Third condition, just now we said that if chords are equal, here so just now we had done if chords AB and CD are equal, the perpendicular bisects the chord. The previous theorem that we did, perpendicular bisects the chord. So I know that if chords are equal, their half will also be equal. In Euclid's theorem, we did that if two things are equal, their halves will also be equal. So half AB equal to half CD. So half AB can be replaced with AM and half CD can be replaced with CN. So we get AM equal to CN, AM equal to CN. That will be our third condition. So we had MN and 90, OA and OC equal, and we have AM equal to CN. Why AM and CN are equal? Because the chords were equal given. So half of AB and half of CD are equal. So half AB is AM and half of CD is CN, AM equal to CN. We have to show this step here. Now we've got the triangles OMA and triangle ONC congruent by RHS, right angle hypotenuse side. And if the triangles are congruent, then OM equal to ON by CPCT. So this is the proof of the theorem that equal chords are equidistant from the center. And remember, the converse of this will also be true, that if distances are equal, OM and ON are equal, if distances are equal, then the chords are equal. Here, the same technique will be followed. The conditions will be different. You will prove the triangles congruent. And once we prove the triangles congruent, if OM and ON are equal, I can say chords are equal, right? So equal chords are equidistant from the center. Converse will be equidistant chords are equal. Okay. So both theorems can be used in the questions that we are about to do. Now we come to exercise 9.2. Two circles of radii 5 and 3 intersect at 2 points and the distance between the center is 4. Find the length of the common chord. So here, when we have two circles, the first circle is having radius of 5. Second circle is having a radius 3 and the distance between the centers is given 4. The second circle is having a radius 3. So your second circle, the first circle is 5, second circle center is this, it is 3. So you have to draw a circle like this. The center of this circle will be inside this circle because the radius of this is 5. So now we have to find out the length of this common chord here. Length of the common chord is AB. This is given 5. Distance between the center is 4 and this distance, small radius is 3. Small radius is 3. Now if you look at 5, 4 and 3, these are Pythagorean triplets. 5 square equal to 4 square plus 3 square, 25 is 25. Whenever we have Pythagorean triplets, we can say that this angle is 90. Therefore, OO dash is perpendicular to AB, right? Once we know that the bigger radius is 5, smaller radius is 3, and the distance between the center is 4, these form a Pythagorean triplet. So this is 90. If this is 90 degrees, then we have applied the theorem that perpendicular from the center bisects the chord. So for AB, this is a chord and the perpendicular bisects the chord. So therefore we can say OA and OB are equal to 3. Perpendicular from center bisects the chord, and therefore we can say the length of AB will be 2 multiplied by 3. So AB value will be 6. Now we move on to question number 2. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord. Two equal chords are intersecting like this. Okay. A, B and C, D. This is called intersecting chord, intersecting at P. Prove that the segments, which are the segments here, PA and PC, PB and PD. We have 4 segments. Segments are portions of length having definite length. So what we need to prove that these segments are equal, corresponding segments. That means PA and PC have to be proved equal. PD and PB have to be equal. So let me redraw this nicely for you. Question number 2. We have a question in which there are two equal chords intersecting each other at a point, and we have to prove that the two segments PAPC and PBPD are equal to each other, right? PA equal to PC, PB equal to PD. Now, this is the center of the circle construction. What are we going to do? We are going to join OP. And not only join OP, we are going to draw OM perpendicular to AB and ON perpendicular to CD. OM perpendicular to AB and ON perpendicular to CD. Given, of course, is that the chords AB and CD are equal. Now we come to the proof of this. For proving this, first we are going to take the triangle OMP and triangle ONP and prove them congruent. You see, these are two small triangles here. We will prove them congruent. M and N are already 90 by construction. By construction, we have drawn perpendiculars. OM equal to ON. Why? Because just now we did the theorem that if chords are equal, AB and CD are equal, so distance of the chords from the centers are equal. Equal chords are equidistant from the center, right? So if chords are equal, AB and CD are equal, the distance OM equal to OM by the theorem. Equal chords are equidistant. Equal chords are equidistant from the center. So the chords were equal, so the distance of the chords from the center will be equal. And of course, third condition, OP is OP. That's an easy condition, that condition common. So we can say that triangles are congruent by RHS. Triangle OMP is congruent to ONP by RHS. And if the triangles are congruent, then we can say PM equal to PN by CPCT. Now, PM equal to PN we have proved. Now we can say that MB is equal to ND. Now, how can we say MB equal to ND? Because this is equal chords. If chords are equal, their halves will also be equal. So half AB equal to half CD. Half of AB can be replaced with MB and half of CD can be replaced with ND. And now, why can we say half of AB is MB? Because we just now did the theorem that perpendicular bisects the chord. This perpendicular is dividing AB into two equal parts. So MB equal to ND because AB and CD are equal given. Therefore, half AB equal to half CD. Right? Half of AB is half CD. And that is why we can say MB equal to ND. Perpendicular is bisecting the chord. Perpendicular bisects the chord. Perpendicular from where? Perpendicular from center. Always bisects the chord. So half AB is half CD. So MB equal to ND. Just add both now. PM plus MB is equal to PN plus ND. PM plus MB equal to PN plus ND. Therefore, what will we get? PB equal to PD. We will get PB equal to PD. Second part. Now, AB and CD were already given equal. AB and CD are already given equal. Just now we have proved PB equal to PD. And all we need to do is subtract. We have already proved PB equal to PD. Subtract that from AB and CD. So AB minus PB is equal to CD minus PD. So when I subtract AB and PB, what is left here? AP. And when I subtract CD and PD, I will get PC. So this is PA equal to PC. So this is an important question. Prove that if chords are equal, the corresponding segments that are found are equal. So this is the proof of that. Now we go to question number 3. If two equal chords intersect within a circle, prove that the line joining the point of intersection to the center makes equal angles. This is a comparatively easier question. AB and CD are equal chords we have to prove that the line drawn from the intersection point, that is P, to the center O, we have to prove that this line makes equal angles with the chord. I have to prove that angle 1 and 2 are equal. So let's do this question number 3. If we are having two chords, again equal chord intersecting at point P, prove that the point of intersection when I join to the center makes equal angles. That means I have to prove that angle 1 equal to 2. Again, given that AB and CD are equal chords are given, we have to prove that 1 equal to 2. Construction, I am going to draw again perpendiculars OM and ON. Construction, I am drawing OM perpendicular to AB and ON perpendicular to CD. So proof, I am going to take the triangles OMP and triangle ONP and prove them congruent. How will I prove them congruent? It is given to me that AB and CD are equal. If chords are equal, the distance from the centers are equal. Equal chords are equidistant. Equal chords are equidistant from the center. So OM is equal to ON. OP equal to OP common. And angle M equal to angle N by construction 90. Therefore, we've got the triangles congruent. OMP and ONP are congruent by RHS. OMP congruent to ONP RHS. And if the triangles are congruent, I can say 1 equal to 2 CPCT. So this is what we had to prove, that the point of intersection makes equal angles with the center. So by proving the triangles congruent, we will be able to get angle 1 equal to 2. We have question number 4. If a line intersects two concentric circles, these are concentric circles. Now, what is the meaning of concentric circle? One circle inside the other. So the center is same, but radius is different. So this is concentric circle. We have to prove that AB equal to CD. For this, what we need to do is draw OM perpendicular to AB. Construction, draw OM perpendicular to AB. Now, this is based on the theorem that the perpendicular bisects the chord. So, if you take the bigger circle, I can say that MA is equal to MD. If you take the bigger circle, this is a perpendicular. Perpendicular will bisect the chord. So, MA equal to MD. If you take the smaller circle, again, BC is a chord, OM is a perpendicular. I can say MB or BM is equal to MC or CM. This part and this part, the chord is getting bisected by this. So in the first part, I got AM equal to MD. Second part, I got BM equal to MC. Now all I need to do is subtract. MA minus MB is equal to MD minus MC. So from MA, if you remove MB, you will get AB. And MD minus MC. From MD, you remove MC, you will get CD. So this is an easy question. We'll get AB equal to CD. Then question number 5. 3 girls, Reshma, Salma, Mandeep, are playing a game by standing on a circle of radius 5. Reshma is throwing the ball to Salma, Salma to Mandeep, Mandeep to Reshma. Distance between Reshma and Salma and between Salma and Mandeep is 6. What is the distance between Reshma and Mandeep? So it's a word problem. This can come as a case study as well. So let us break down this question into 3 parts. The first part saying that there are 3 girls on a circle of radius 5. Okay, so let's draw this figure. Reshma, Salma, Mandeep. So let us represent them by R, S, and M. And the radius of this circle is given to us as 5. Distance between Reshma and Salma is 6. Distance between Salma and Mandeep is given 6. Okay, so radius is 5 meter. RS and SM is 6 meter. Question is to find the distance between Reshma and Mandeep, right? The distance between Reshma and Mandeep. That means we have to find out RM. So let us join OS, and when I join OS, that also becomes the radius, that will become 5. Now, first of all, let us understand that this figure is formed when I join these 4 points ORSM. This becomes a kite because a pair of adjacent sides are equal. OR equal to OM and RS equal to SM. This is equal to 5 and this is equal to 6. Both these conditions are given. Therefore, ORSM is a kite. Now, if I am proving this is a kite, I know that this is going to be 90. Diagonals of a kite intersect at 90. Okay, so this angle is 90 degrees. Now, this is 5, this is 6, and this is 5. I can find out the area of this triangle by using Heron's formula. So triangle ORS, we can find out the area of this by using Heron's formula. If you remember Heron's formula, S is A plus B plus C by 2, that is sum of the 3 sides. So we have one side as 5, the other side as 5, because this is also radius, this is also radius, and distance between Reshma and Salma is 6. So 16 upon 2, S is 8. And if you remember, area formula was S minus A, S minus B, S minus C. So area is going to be 8. 8 minus first side, 5. 8 minus second side, again 5. 8 minus 6, third side. We will be able to solve this and get the area of triangle ORS. This will be 8, 3, 3, 2. So area will be 2 into 2. I'm going to factorize this into 3 into 3 into 2. So this is a group. 2 into 2 into 3. So area is coming 12 meters square. Area is coming 12 meters square. Now, if the area of triangle ORS is 12, the area of triangle OSM will also be 12, and therefore, if these two are 12 each, area of the full figure ORSM will be 24 meters square. Area of the full figure will be 24 meters square. Now we know that area of a kite is half product of the diagonals. One diagonal is 5, and the question is find out the other diagonal, that is RM. So area of ORSM kite can also be found by half D1 into D2. Area we have already found out 24. One diagonal, that is OS, is already given 5, and the second diagonal is what we need to find, that is RM. Cross multiply, we get 48, and the 5 comes down. So the value of RM, that is distance between Reshma and Mandeep, will come 9.6 meters. So this is an important question to find out the distance between Reshma and Mandeep, and the answer should come 9.6. Question number 6, a circular park of radius 20 meters is situated in a colony. 3 boys, Ankur, Syed and David, are sitting at equal distance on the boundary, and they are having a toy telephone. Find the length of the string. Again, an important question. Question number 5, 3 boys, Ankur, Syed and David are sitting at equal distances. That means if I join this, it's going to become an equilateral triangle, right? So this is the circle, and I'm going to join this, and equally I'm going to get an equilateral triangle. Ankur, Syed and David sitting in the boundary at equal distances. We have to find out the length of the string. Let us assume the length of the string is X. What is given to us is that They are sitting at equal distances. So AS equal to SD equal to AD. The radius of this is given 20. The radius of this is given 20. The radius of the circle is 20. So this portions, if I join, this is going to be 20 each. Now what I'm going to do is I'm going to extend this line till it meets this M. So construction extend AO to M. Now remember, in an equilateral triangle, when I am going to join this AM is going to be the perpendicular bisector. The line here is going to be the perpendicular bisector. Okay, when I join the radius and extend it, that becomes a perpendicular bisector. So if this is x, this is going to become x by 2. So solution, AM will become perpendicular bisector of SD. By construction, when I'm extending this, since it's an equilateral triangle, the altitude also bisects the base. So here we can say that AM is the perpendicular bisector of SD. So SM will be half of x or x by 2. We have represented this by x by 2. Now another important thing is that this point of intersection is also known as the centroid of the triangle. This is the centroid of the triangle. These radius is actually going to bisect these angles as well, because it's an equilateral triangle. Only for equilateral triangle this works. And the point of intersection of the medians, this is also a median. Why? Because as I told you, this line is a perpendicular bisector. If it is a bisector, these are midpoints. So when I'm going to join these three medians, the point of intersection of the three medians is known as the centroid. So this is a median. If I extend this, it is going to intersect at the midpoint of this side. If I extend this, I'm going to get the midpoint of this side. These will all be midpoints. So this point is centroid. And there is a theorem which says that centroid divides the median in the ratio 2:1. The centroid divides the median in the ratio 2:1. So AO by OM will be 2/1. This is the median. This whole line AM is the median. AM is the median. If AM is the median, the center divides AM in two parts. From A to O is 2 parts and O to M is smaller portion 1 part. So AO is given already 20. OM we do not know. That ratio of this AO by OM will be 2:1. So twice of OM is 20. So OM value will be 20 by 2, that is 10. So we know that this is 10. Now this in triangle OMS, this is a right angle triangle. So we can use Pythagoras. 20 square equal to 10 square plus x by 2 whole square. 20 square, that is hypotenuse square, is equal to sum of perpendicular square plus base square. 20 square is 10 square plus x square. 400 minus 100 is x square by 4. When I solve x by 2 whole square, I'll get this. So 300 equal to x square by 4. 300 equal to x square by 4. Cross multiply, x square is 4 into 300. X will be root of 1200. X will be root of 1200. Now, if I factorize this, I'm going to get 2 into 2 into 3 into 10 into 10. I need to make groups. So what I'm going to get? I'm going to get 2 groups. One is of 2, the other is of 10. So x will be 2 into 10 into root 3 doesn't have any pair. 3 doesn't have a pair, so that will remain alone. So 20 root 3. The value of x will be 20 root 3 meters. Now the value of root 3, you should remember 1.732. So the value of x will be 20 into 1.732. So value of x 34.64 meters. Now the question was, what is the length of the string? So therefore we can say length of the string will be 34.64 meters.